an element is a substance that's made up of the same kind of atoms, right? Yeah, so element contains a lot of atoms. So when you watch that video, you see that we are using the analogy of the biscuit, where we say the wrapper or the container that holds the biscuits, the individual biscuits inside there, that container is the element, and then all the individual biscuits inside are the atoms. And if you see that they have they look the same, but they have different mass. If you want to measure them very well, they differ. Some of them are cracked, some of them there is a bit of deviation, not perfectly the same, even though their masses are close. Indirectly, some way, somehow, some way more than the others, right? But they are the one that actually take part in a chemical reaction, because they are the one that we eat. We don't eat the rubber. So when we refer to element, we also use the analogy of family, where a family name is there, and then inside another family name, you have family members. So every family member have their own names, like they have an own first name, but then they always keep the surname of the family. Let's say the Johnson family. The Johnson family may have different, like Junior may have Godson in the family, but everywhere they go, they actually add their surname to themselves so that they can be attached to that family. That's the same analogy that we are going to use. Isotopes, right? Let's try to understand isotopes. From the name itself, all these names are not ours, right? These terms are not ours. So we all took it from somewhere. Isotopes. Iso, right? Iso is it means same or similar, similar. And then topes come from some Greek or Latin word, means topos. Topos means place, right? Place. That's what my research got me. Like topos means place and iso means same. So we are going to talk about isomer. We're going to talk about isobar. Whenever you hear that iso, it just means same something. Okay, so same place here, isotopes. But then this place that we are referring to refers to the place on the periodic table. So we are going to consider the periodic table as houses of families, right? So this is one house, this is another house. Every element, right? So what you are seeing is the periodic table of elements. So what you are seeing on the periodic table, they are all elements, right? Not the atoms. We took time to explain that in that video, right? So every element that you are seeing, consider it as a house of a family. So let's say the hydrogen family, the helium family. Just like how you go to a community where they have different houses. This is the Johnson family house. This is the whatever family house, right? The Henry's family house, the Opoku's family house, the whatever you can think of, your family name, yeah, your house, yeah, right? That's the name of the family house, but that means that if you go to that house, you are going to find members of that family that bearing that particular surname, but each and every one of them have their own first name in that, right? So isotopes means same place, means the same family, same house, same position. So isotopes is so if you go to this hydrogen family, hydrogen house, you go enter hydrogen element, you are going to see members of it. So hydrogen contains atoms. Atoms are the members of the family hydrogen. Okay. So isotope just means that if you go to the same place, atoms belonging to the same place, atom belonging to the same element, atom belonging to the same family, right? If you go to helium also have its isotope. The isotope may be 1, 2, 3, 4. Family. It's a family, right? Family member. It can be 1, 2, 3, or 4. As long as you have a family, there's always going to be a member, right? So hydrogen will be there. Hydrogen is like a family. It's an element. If you enter that family house, you are going to see the atoms inside. The atoms are the members of this particular family. So the hydrogen has isotopes. So isotopes are members of a family, of the same family. They are members of the same family, but they just have different what? Different surname. Oh, sorry, different first name. Okay, so you have Johnson Jr., Johnson, George, Johnson. What are the names there, right? Henry, yeah. So hydrogen is an element, it's a house of family of atoms. So if you enter hydrogen, you should be able to see the atoms inside. All the possible atoms inside are called isotopes, because isotopes are atoms of the same element. Isotopes are atoms of the same element. These are like members of the same family. So they are atoms of the same element that have the same name, family name, but different first names. Okay, So the difference between the atoms of that family, of a particular family, is actually here it's not going to be in first name, but it's going to be in neutron number. So they are all hydrogen, all right. They are all located in the same family. They all have the same proton number. That's 111. The proton number determines the position. The proton number determines where you are on the periodic table. So if you go to hydrogen, proton number is 1, right? So they all have, if all atoms are there, then they all have the same proton number. But then, even though they are all in the same place, they differ in something. The only thing that they differ in now is the neutron number. So they have different neutron numbers, right? They have different neutron numbers in their nucleus. Basically, that's what made the difference. But as for the position, as for the place, is determined by the proton, and then the two proton determine the position. So same position, same proton, same location, yes, same family. However you can think of it. But then I want you to get it like at the layman level what this actually means. Okay, so we have isotopes now. Now let's get to the definition of isotopes. Yeah, with this definition, you say isotopes are atoms of the same element, right? If you follow whatever I said earlier, you see that isotopes are atoms of the same element having the same atomic number. I mean, they have the same proton number, but the proton number determines the position on the periodic table, where you are on the periodic table. If you put on number 2, then you're on position 2. That's helium. If you put on number 3, you're on position 3 on the periodic table. That's 3. That's lithium. So they are atoms of the same element. Element is the family name, and then if you enter that family house, you'll be able to see atoms inside. So they are all atoms of the same element, having the same atomic number or proton number, but different mass numbers due to differences in their neutron numbers. So they have different mass numbers due to differences in the neutron numbers. Because if you have an element X here, you see the proton number Z is here and A is here, and then we say A is equal to a neutron plus the proton number. The proton number usually use Z for it. So A is the atomic number, right? This is the mass number. A is the mass number and Z is the atomic number. So if you have N plus Z, and then this one is a constant, they say this one is the same, and then we are seeing this one vary, then the only difference is going to be due to neutron number. So they are going to have different neutron numbers inside. So we are going to look at some examples of this element. Yes, so some of the examples of these elements. So if you take hydrogen, for example, if you take hydrogen 1, so hydrogen, this is hydrogen element, right? We said that this is the hydrogen element, but then we need the hydrogen atoms. The atoms that are inside here are hydrogen 1. We also have 2, 3. These are the common isotopes of hydrogen. You see that there is hydrogen of mass number 1, mass number 2, mass number 3, but you see the proton numbers are the same. So this one determines the position. So it means that they are all hydrogen, meaning they are all in this house. They are all in this position in this house. But then inside that house, the house is the element, right? If you enter that house, you're going to see these 3 atoms. These 3 atoms inside this house. These 3 atoms are the members of the family hydrogen, and they are called isotopes. So isotopes are atoms of the same element. So these are the atoms of the same element of the same family, having the same mass, the same mass number, which is the proton number. Having the same atomic number. Atomic number is the one that's proton number, but different mass numbers, which is the A here at the top. Why? Because they have different neutron numbers. So now there are common name for this one. This is the protium. We call it the protium. This is the hydrogen with the mass number 2. We call it deuterium, right? Yeah. And then this tritium, however you call it, however a teacher calls it for you. That's it. So yeah, so you have this for hydrogen. So the atoms of the same element having the same mass number, the same proton number or the same atomic number, but different mass numbers. Why is there difference in the mass number? Because there's difference in the neutron number. So you need to actually state all that if you refer to this definition. Atoms of the same element having the same atomic number, that's proton number, but different mass numbers due to differences in their neutron numbers. So the neutron numbers that differ when you get to a particular family. So you have other examples of isotopes, right? So let's go to another house. Let's go to the house carbon. Carbon is a common element that we'll be seeing mostly, and then we have isotopes of carbon. So if we have carbon is 6, right? So the various isotopes of carbon, or the various atoms inside, we have carbon 12, so we have 6, 12. We have carbon 13, so it's carbon 13. We also have carbon 14, is 6. This one should be 6. Yeah. So carbon 14. This one is for dating, is for determining ages of stuff, right? It's used in archaeology or and all that. So yeah, so these are the isotopes of carbon. We have chlorine. Chlorine is, I think, atomic number was 17, right? Yeah, it's 17. 17. So chlorine 17 Cl. We have chlorine 35, right? And chlorine 37. The common one, the most stable ones. Common chlorine 35, and then chlorine 37. Right? The same thing applies to oxygen. Oxygen, right? Oxygen, we have oxygen 16. Yeah, is that oxygen, right? Yeah, we have oxygen 16 and oxygen 18. Yeah, we have oxygen 16 and oxygen, is it? Yeah, 18. Yeah, it's oxygen 18 or 17. Yeah, so these are the common elements and their isotopes, right? So these are the isotopes. So isotopes are atoms of the same element having the same I want to say mass number again, having the same atomic number, which is the proton number, but different mass number, which is the A. Why is that different? Because there's difference in their neutron numbers, and the common ones are these. So carbon 6, carbon 12, carbon 13, carbon 14, oxygen 16, oxygen 18, chlorine 35, chlorine 37. Yes, this is what isotopes mean. Same place, same position, same house, same family. Isotopes. Same place, same position on the periodic table. Yes, so now let's look into next. There's another concept waiting for us called the isobars. Let's see what they also mean in the next session.